Question number 28. Find the acceleration of the block of mass capital M in the situation 6E10 figure shown. The coefficient of friction between the two blocks is mu1, and that between the bigger block and the ground is mu2. So coefficient of friction between these two blocks is mu1, and here it is mu2. Now we can consider the motion of both masses. So here one thing is very clear. When this mass capital M moves x distance in this direction, so length of the string released for small m mass will be x here, and the same distance, this will move through distance x. So same distance of the string will also be released. So we can say this is x and this is x. So total length for small m in this case will be 2x. So acceleration of small m is a, and that of capital M is a by 2. So it is better to write it as 2a and that of capital M as a. So it will be easy for calculation purpose. Now we can consider the different forces acting on mass small m. So this is small m. Here its weight mg will act in downward direction, and there will be friction between these two surfaces since this block is moving in downward direction. So friction is suppose Fr1, and tension is also there in upward direction. This is T, and this block is moving in this direction with acceleration 2a. And now, since this mass capital M moves in rightward direction, so there will be a pseudo force on this smaller block in this direction. So it will be MA, and this will behave like a normal reaction for this block. So from where we can get the value of friction. So we can say friction, suppose friction number 1, we write here because friction will also be there. So it will be equal to mu1 times MA. Now let's balance all the forces. So here mg minus friction 1 minus tension equal to m times 2a. Here friction 1 is mu1 times ma. So mg minus mu1 times ma minus tension equal to 2ma, or we can write tension equal to, this is shifted to RHS and this will shift to LHS. So mg minus mu1 ma plus, sorry, not plus, but minus 2ma, which can be written as T equals mg minus ma times mu1 plus 2. So we have got the expression for tensor. Suppose this is equation number 1. Now we can consider the motion of block capital M. So let's draw separate diagram. So this is block capital M. There will be friction. Suppose this is Fr2 in this direction, and its weight capital Mg will act in downward direction, and normal reaction, suppose this is R2, will act in this direction. And there was one force that we have seen in this, that was R1 in previous case. This body is exerting force in this direction because of pseudo force, because this capital mass moves in this direction. So there will be a force that will be called pseudo force, and that will be equal to MA in this direction. So here we have to consider this force also in this direction, that is MA. And this block of capital M mass is moving with acceleration A in this direction. Here, one more thing is there. One tension is in this direction, another tension is in this direction. And apart from that, in previous case, there was friction in upward direction. So according to Newton's third law, there is equal and opposite reaction. So there will be one friction in downward direction, and that will have same value, friction 1. And there is tension in the string also in the same direction, T, as you have seen here. This is, if this tension is action, then there must be a reaction force also. So tension is in this direction, this tension will be in this direction, this tension will also be in this direction. So we have got all forces. Now let's balance the forces in vertical direction. So R2 is in upward direction, and other forces, one is mg, capital Mg, another is FR1, and next one is tensor. Now we can put the values of FR1 and tension. So R2 equal to capital Mg plus FR1 is just mu1 times MA. We have already evaluated here. So plus value of tension we have to put from here, this Mg minus MA mu1 plus 2. So let's write it. So it will become Mg minus MA times mu1 plus 2. Now we open the bracket. So capital Mg plus mu1 MA plus small mg minus here MA mu1 minus 2 MA. So this mu1 MA will cancel out, and we will be left with, this is capital Mg, this is small mg. So we can write it as capital M plus small m times G minus 2 MA. This is value of R2. Now let's balance the horizontal forces. Since this block is moving with acceleration A in this direction, so we can say MA is equal to total forces, tension plus tension, this tension and this tension, reduced by frictional force, and this R1 is also acting in this direction. So frictional force, so FR2 minus R1. Let's write the value of tension. So twice of, we have got the value of tension, this thing, or we can check in the back, this Mg minus MA plus mu1 plus 2. So that value we can put here. So Mg minus MA times mu1 plus 2 minus friction 2 will be mu2 here. Coefficient of friction between ground and the block is mu2 times R2, and R2 we have got this. So R2 we can write small m plus capital M times G minus 2 MA. So minus R1. So R1 is just MA. Now we open the brackets. So 2mg minus this 2 will get multiplied to this number also. So 2MA mu1, and this will become 2 to the 4 minus 4MA minus From here, this mu2 times small mg minus mu2 times capital Mg. And when this mu2 is multiplied to this number, this will become positive twice of mu2 times small ma minus ma is equal to capital Ma. Now we can further simplify. So we can write all terms containing A in LHS. So if we write A outside, so we will get M from here. Then here, this term, so we'll give plus M. Then A containing term is this. So this will become minus. So we are taking it to LHS. This will become plus twice of mu1 small m. And from here, this will become plus 4m minus this term will become negative. We are shifting to LHS. So this will become 2 mu2 times small m equal to this term will remain as it is 2 mg minus this minus mu2 mg minus mu2 capital mg. So let's write it further. It will become A times here. This is small m, this is 4m. So this will become 5m. So capital M plus 5 small m plus here we have considered this. Now from here we can take out 2m outside. So mu1 minus mu2 will be left. So plus 2m outside mu1 minus mu2 equal to, in this side, we can write 2mg minus. We can take out mu2g. So if we take out mu2g, then inside capital M and small m will be left and both will be positive. So small m plus capital M. Our concern is to get acceleration of bigger block. So we can write it as small a equals 2mg minus mu2g times small m plus capital M divided by capital M plus 5 small m plus twice of m times mu1 minus mu2. And that is our answer. Thank you for watching.